Hello everyone. So I'm gonna wait a few minutes for everyone to come in and then we're gonna start. Hello Mafias. How's the sound? Hello Chris. Okay, so I think we're gonna start now. So I posted a small poll on Twitter earlier today, and you want me to code JS API for dependencies. So that's what we're gonna do today. And I must say, it's not gonna be coded from ground up because there was some work already done in the past, but it wasn't landed. So I think we're gonna start by looking at this old PR and then figuring our way from it. Of course, we'll have to port it to JSON.ops because as far as I remember, it was coded using flat buffers. So we'll have to translate it to this new dispatch mechanism that we use now. And yeah, let's see how it goes. I believe this is this one? Yeah, I think so. Yeah, that's the one. So most of the work was already done here, but there were some problems with isolate ownership. And those problems are fixed now. So this should be pretty straightforward because we've got most of the APIs we need already in place. And I'm talking about the deps method. Yeah, so there's this structure with two JSON method, and that's basically what we're gonna need today. So we're gonna add a function called deps to Deno object, and then we're gonna call the Rust site and ask for all the dependencies of the given module. So yeah, let's add new export here. Let's say we name it deps and then a file called deps dependencies.ts. Let's go to some other file and let's copy over everything because we're just gonna change a few constants here and there. So yeah, dispatch JSON, this is what we need and want. Yeah, let's remove this dog string for now. And yeah, I think we're gonna provide both sync and async version for this. It's gonna be actually, we just need to implement one of them. I think this will be sync, and then the async version will just await the promise. Okay, so let's do deps sync and deps. So we're gonna ask for dependencies of a certain module, and you reference modules in Deno using URLs. So the only parameter that this function is gonna take is URL. and the same in here. Yeah. Okay, so this is URL, and now we need to change this to op.deps, and we're gonna need to add this constant to JS and then to Rust as well. So on Monday, in the Monday stream, we were trying to refactor the API for dispatch, but after some later talk, we figured out that adding promise IDs might not be the best idea at the moment. So let's keep with the old dispatch mechanism. Let's add a new op ID that's hard coded. We refactor it in the other PR, the dispatch PR. Okay, so we have op.deps. Actually, maybe let's just start deps sync. Yeah, so this is deps sync. Yeah, so now ops mod rs, and we're gonna add another constant here for the deps op, and we're gonna write a new handler. So this will be op deps, and then dispatch JSON dispatch, and in here this will be called deps module and op deps. So yeah, let's add a new module, and let's register it here. Oh, sorry. So mod deps, and yeah, again, let's go to some of the other files and let's copy those imports, because basically this will be exactly the same. Oh, and copyright as well. So we're adding op.deps, then we have args. Args is a JSON value in here, so it's already deserialized control buffer that we know is a JSON, and now we're gonna add a new struct that reflects what we send from TS. So if in here we send args object that consists only of single field called URL, then we need the same thing in here. So this will be deps args and URL, and now we're gonna deserialize the JSON message. So we're using serda JSON, and we just need to give it the type that we want to deserialize this value we have. Okay, so for now this goes, and in here let's have an empty object, and in here what are we going to return? So we have this toJSON method on modules. So it's a string, and yeah, it returns the array. Does it? Yeah, array that will have. Yeah, okay, so this will be a 2-element array. The first one is gonna be the name of the module, so this will actually be a URL, I think, and then another nested array with all the dependencies. Okay, so let's do that. So, wait a minute, is it the same for all of them? So self-deps, and then each dependency will be toJSON. Okay, so this we probably need a new type for it. So deps array, and this will be string deps array. Can we do that? Is circular. Okay. Okay, let's start just with any, and we're gonna figure it out later. So to do figure out better return type, and I'm gonna need to suppress ESLint. It's gonna complain because we have this any return type here, and we're running in strict mode, I think, so there should be no any return types. So yeah, we'll get to this later after we actually get something from Rust. Okay, so we have handler in JS, we have module in Rust. Now we just need to get the deps structure, and then we can return it to JS. Okay, let's go back to the PR that was already in place and see how it was done before. Okay, worker, fetch module metadata and maybe compile. I think this no longer exists. It was removed during Deno.deps refactor. But I think I know what function currently does the same thing. So let's see, state main module, and this is referrer, I think. Okay, so actually I think this PR was just exposing API for getting dependencies of currently running main module. I don't think it's that useful actually. I think programmatic access to get dependencies of any module is what we want. So let's do that. Yeah, one thing to keep in mind then is that fetch module metadata may be compiled is used during boot, so it will print downloading and compiling messages. Yeah, so this sentence still holds true, and we will get compiling something or downloading something messages printed to standard error when we'll retrieve dependencies for the URL we want. But I think it's fine for now. Okay, and in here, state modules deps, and then you give the module name. Okay, let's look for this deps function in modules. Yeah, I think it's this one, deps new self module. Yes. Yes. Okay, so first of all, once we send the URL to Rust, we want to make sure that it's actually a valid specifier. And in Deno we have some structure called module specifier. That is used to like describe everything that is actually a module that should be loaded by V8. And yeah, I need to check the API. So it should be resolve import. Is that what we want? Let me think. So we're gonna be in a certain file. Do we want to retrieve dependencies by a relative path? Yeah, probably. But then we need to have the referrer, which is a file from within, a file from which we're calling. That might be available using window.location, but I'm gonna have to check. Okay, so first thing first, let's start simply, and yeah, let's use this resolve URL or path. So basically this method takes a single specifier that either must be a valid URL or must be a valid path. and we'll start with that. So if it's a path, it will be resolved in context of current directory. Okay, so resolve URL or path. Yep. And now this will be args URL, and resolve URL path returns result with module resolution error. So we can just use a question mark here, because this module resolution error can be downcast into error box, and this is a helper type used throughout Deno CLI to like be able to just capture all errors and translate them into something that can be and serialized into something that can be sent to JS to print a nice JS error. Okay, so if it's not a valid specifier, then this function will return error. And now we need to call into the deps API of modules. So we need to check where do modules live right now. Are they on a state? Let's see, state.rs modules. Yep. Okay, so that's pretty good. We have state as a first argument here. So let's do deps.json equals state.modules.deps. And now our module specifier that we're gonna cast to string. Does that work? State modules deps. Let's see. Okay, let's try to compile this. Okay, this might take a second or two. Modules.rs fn deps. Yeah, URL, which is a string reference to a string. So no, actually we should add reference sign here. And since this will be a string, I'm pretty sure we can just return it like this. And then in here we'll again have, yeah, so this is this type that we need to work on. Okay, still compiling. All right, so let's quickly add like one off file that we're gonna use to test this functionality manually at first, and then we'll add a unit test. The reason why I'm starting with just a simple file is the fact that unit tests take a few minutes to run, and we want to check what we're doing right now quickly. Okay, so just console log Deno.deps sync, and let's add something like Deno.land/welcome ts. No, it's not a good example because this file has no dependencies. Okay, let's see some other file in registry that is available that will have some dependencies. So std and maybe http. I think file server will have some deps. Yeah, it takes a second to load. Or 2 seconds. Oh, 5 or 3. That's not good. We're gonna report it in chat later. Okay, wait a second. I can just test it locally. Let's see, then std http file server.ts. Yep. Okay, let's cut it. Yeah, it has some depths. Okay, that's gonna be a good example for now. So Deno/land/std/http/file server.ts. Yeah. Okay, let's wait for the compilation and we'll see what we have. So let's think a bit about the return type of this method. So this toJSON method available here returns an array that the first key of is a string, and the second key, sorry, the second element is a nested array of string and then another array. So it's self-referential type, I guess. Yeah, we might want to rewrite this method to return objects instead of arrays. Let's see where it's used. Okay, here and here. Is that it? Let's see. .deps modules, no deps. CLIs. Okay, so it's actually used in Deno info command. So if we do Deno info, okay, I probably need to increase the font size so you guys can see, and let's move this here. Oh, yeah, compiling Deno takes a lot of CPU and my computer is not that new, so std http file server.ts, and I believe we'll see the output of this deps method in here. This tree structure should appear in here. Okay, compiling. Yeah, so this deps actually uses this. Yeah, so we have this Deno info command that basically shows you all info Deno is aware about the file, including dependencies, the source map for compiled JS file, the compiled JS file, and the location of the file. And keep in mind that this location is cached location on your local computer, because on first run of remote module, Deno will download the file and then cache it internally for further use. So unless you provide -r or -- reload, Deno will not download the module file again. Okay, so let's see how it's done in here. If let some ref deps, that's nice. Then for the print, okay, flat some dependencies, a dep name. Yeah, but it's not stringifying it. So I guess we can just change this to JSON method. That would be nice. Yeah, so how's the compilation? It's still going. Oh. Okay, so let's do some more changes before compilation ends. It should be a lot faster on the next changes because I switched branches and I think I forgot to build it first before starting stream, so sorry for that. Okay, back to the modules RS, and let's see. Maybe deps unwrap to JSON. Yeah. Let's go to this toJSON method, and Actually, I'm going to keep this method and add another one so we don't break the test, and then we can switch. So we do to JSON object, and let's change it to manually construct the object. Oh, sorry. So this will be actually an array of dependencies. Yeah, and we want to change this bit. So we'll do like name, then we'll put the name, and then we'll add deps, which is an array of such objects, and this should be fairly easy to type in TypeScript, I think. So maybe just let's use interface. So deps res, and this will be name string, and deps will it be returned always? Yeah. So deps is deps array of deps res. Why cannot is declared here? Oh, okay, that's fine. Deps res. So we should be able to remove both of these and these, and compilation is still going, so we're gonna have to wait. Okay, let's enlarge this one as well. Can you guys see what's going on in terminal? Is the font size fine for you? Okay, thanks for the info. I think you have like 2 minutes delay, but I can't help that. So let's finish for this compilation to let's wait for this compilation to finish, and then we can move on. Actually, let's not waste time, and let's start writing a unit test for this. So we're gonna add another file in here, deps test.ts, and we're gonna need some permissions for this deps API. Oh, wait a second, deps expects this module to already be loaded, I think. So deps new module self helper. Okay, module name. If scene contains s else get children. Okay, so I think this is gonna explode when we run it at first, because the deps method on modules expects that the module is already loaded, I think. So when we pass a URL that hasn't been loaded in the current process, it's gonna crash, but we're gonna change that in a minute. So yeah, it's still compiling. Did it crash, or is it actually doing something? Oh, I think building Deno and running OBS is too much for my MacBook. Yeah, it's doing something. Okay, so yeah, so to make this work with URLs that haven't been loaded before, we're gonna need to load these modules into V8 first. And now I'm gonna tell you how module loading works in Deno anyway. So we have some stuff that is in CLI and some stuff that is in core. So core is a crate that provides bare minimum, including bindings to V8 isolate and module system. And the CLI crate contains all the code that is actually used to build the Deno binary. And state is a struct that, well, encapsulate most of the stuff that is going on in CLI. And actually it's the job of the state to load the module into V8. And this is done in here. We have this trait loader that is implemented for thread safe state. And this trait requires two methods. One is resolve, which takes the specifier and referrer and then returns the actual module URL. And the other is load, which is actually responsible for loading given module. And this is interesting in here because we're not just loading something from URL, because you cannot load TypeScript into V8. And actually in this step, we're compiling the TS modules on the fly to JS, and only then, after the compilation is done, we hand them to V8 to be loaded. So this fetch compiled module, this method is implemented also on the state, and currently it's hard coded because we support 3 media types in Deno. That is JSON, which is just passed through. That is JavaScript, that of course is passed through unless you have check.js option in your TS config set to true. Then we'll run the JS files through the TypeScript compiler as well. And of course, for TypeScript, we're always compiling the files. So yeah, this method basically fetches the original file. So in our test, we have this URL, and it's a TS file. So what's gonna happen when Deno encounters this import statement for this file? This method, fetch compiled module, will be called with module specifier that is exactly the same as this one, so TS. Then it's gonna fetch this file, so actually download the file from the internet. And then after successful download, depending on the media type of the file, it will be run through a certain compiler, in this case the TS compiler. So let's go to ts.rs inside compilers directory and look for compile async method. Okay, so compile async is actually doing a lot of things. First of all, it's taking care of caching. So if you request the same file a few times, it's only downloaded and compiled once. Then if you did not specify the reload flag, compiler will look for already compiled version of your file on your disk. So a few minutes ago I showed you this Deno info command, and then you had the path inside Deno directory to the compiled file. And this is quite simple mechanism right now. So we basically take the whole source code of the file, Deno version, and then contents of your TS config files. And if all 3 of them match, then we take the already compiled version from disk, so we don't have to spin up TS compiler. And then if both of these previous conditionals fail, so we did not compile the file yet, and we do not have it in cache, disk cache, then we're actually gonna compile the file using TS compiler. So in here you can see bootstrapping of TS compiler. That means we're creating brand new worker, which is a wrapper around new V8 isolate. And then we're loading the compiler runtime that you can see in compiler.ts file. So the whole code in this file is used only by compiler and loaded by compiler isolate. And then we're actually requesting the compiler to process the file and give us back the JS file. And this is all done in here, but I'm not gonna dive more into that right now. Oh, okay, so compilation finished, but we have a problem because of this opening brace. Oh yeah, that's not good. So modules, and let's see. Okay, we need to use double braces because braces in Rust are used as to mark that a value should be interpolated. And yeah, so if you want to actually use a brace in format string in Rust, you use double braces, so escaping the interpolation symbol. Okay, please compile, please compile. Oh, that's almost fine. So yeah, we need a reference in here. No method named deps found for arc. Oh, okay, so modules are inside a mutex. We need to lock it to get access. And yeah, so yeah, this is not needed. Nor this, nor this, nor this. And yeah, so let modules equals state modules lock unwrap, I think. And in here it's just modules, and we need a reference to URL here. And let's compile again. Oh yeah, modules. And yeah, we want to call lock. Okay, deps JSON. Yeah, so this is just deps, and let deps JSON string equal to deps to JSON object. And we're gonna return this deps JSON string. Yeah, so as you can see, once we compiled all the stuff, now the incremental compilation is rather fast. Okay, so it's an option returned from deps. Yes, it is. So function deps, option deps, return new, self helper, and helper returns an option. Can it short circuit, and when? Map, some. Why does it return option if in both arms of the conditional, you have some. Yeah, that's interesting. Let's leave it as is and just do unwrap. This might bite us later, but we'll figure it out. Yeah, it built. Okay, let's see. Deno.deps and test TS. Okay, does not exist on type of Deno. Yeah, so we added a new export from Deno.ts, and we need to also add it to runtime declaration file. So lib Deno runtime dts. Yeah, and yeah, this is gonna be tricky. So basically we need to add this deps sync in two places. First, we need to declare a new namespace. So this will be deps, and we'll just, okay, so URL js.deps dts, is that right? Yeah, probably. So export function deps sync, and I'm just gonna use some other function declaration in here. Oh, right. Okay, so no, I don't actually need to do that. Yeah, so we take URL that is a string and we return deps rest. So yeah, we're gonna need to put this interface in here as well. And deps res. And I think we're gonna need to declare it again inside main declaration. So if we search for chown, yeah, it's up top where we declare the whole Deno interface, and then it's down again, is it not? Come on. So chown sync, it's defined only once. That's interesting. That's interesting. Okay, so let's move the whole declaration here. So I'm like wiggling around in here because this was auto-generated before, and right now this mechanism to auto-generate it has been removed, but it should be brought back shortly. Okay, does this look right? Let's see if this compiles. So cargo build. Okay, so one more thing. Why did it compile, but then we couldn't run the file? So actually we had a successful compilation, and then during the compilation we create a snapshot of the whole runtime. So everything that's exported from Deno.ts file, it's snapshotted for fast load time on subsequent access. So we do not parse the whole JS file over and over again, but we use v8 snapshot, and everything was fine there. But then we have this lib Deno runtime DTS, which is given to TypeScript compiler, and since we're running test.ts file, it was first run through the TypeScript compiler, but the declarations for the runtime we had inside the compiler did not have this deps sync method, so we just added it, and let's see if this works. Oh yeah, that's better. Let's see what's wrong. Rust backtrace full. So where do we panic? Deps option. Okay, yeah, so this is the panic that I told you about. We did not load this module before, and that's why we're getting okay, so I think there's implicit. No, it's not. What's going on? Okay, so the problem is we're trying to get dependencies of a module which was not loaded into V8, so we do not have all the references to its dependencies, and we're unwrapping the option deps, and actually we're getting none instead of some. So what I'm gonna do for now, let's change this to get dependencies of this file we're running now, so test.ts. Does that work? Yeah, that's better. So when we ask for the dependencies of the module that we already have loaded, it works, and it doesn't if this is a module that wasn't seen before. So let's fix this now. And to do that, we're gonna load this whole module and its dependencies in this method. So yeah, module specifier. If it's a valid module specifier, we can load the module and its dependencies. And let's once again quickly go to the to this PR. Yeah, but it was only working for main module that was loaded on startup. Okay, so actually I think we're gonna need to use this load method. Source code info future. No, this is loaded. This method is called from within modules rs, I think. So let's see. Yeah, add root. So what we're trying to do is actually do something like dynamic import, but we don't want to import and evaluate the module. We just want to download it, parse it, but not evaluate it. So we're gonna need to look for oh wait, what are we gonna look for? I think we need to go to librs, which is like an entry point, and we have this info command that print file info. Yeah, actually, yeah, this is the stuff that we're interested about. So I'm just gonna copy paste this whole function and strip it a bit inside the deps rs file. So let's see what's going on in here. Print file info takes worker, then we get the state from the worker, and then we fetch the file. Yeah, if file is not found, then the error was printed. That's not what we want. And then out file, fetch compiled file. Yeah. Yeah, and this is the place we're interested in. So state modules wrap compiled. Yeah, okay, so I removed too much. So this compiled, so this is a so-called source file structure. Yeah, file fetcher, it has URL, so the URL you use to load the module. File name, yeah, I think this is the file name for cached version, or just the same file name as URL for local files. Media type and the actual source code. Yeah, so this compiled is what we're interested in. So this is yeah, map error, this is not, and we have compiled. Yeah, so actually we're gonna need to change that deps is an async op, not a sync one, because all the stuff in here, like fetch source file and fetch compiled file, these are asynchronous functions. They return futures. So let's see. Yeah, module specifier, we have that, and then, so we don't need that, we don't need that. So this is let future. No, actually not. Okay, we're gonna need to do this, because you cannot have the same reference used. And we're gonna need to copy state, yeah, sorry, to clone state, state.clone, and from within we're gonna do this. So yeah, and this is gonna be async, and we need to remove this. So let's go through this line by line. So first of all, we're calling fetch source file async, which returns a future, and then if this future is resolved, so we get OK result, then we're gonna fetch compiled file, and only after we fetch the compiled file we get to take its dependencies. And I think this should be compiled.url to string. Yeah, let's see if this compiles. Okay, but first of all, let's change this to async, send async, and this is an async function as well, and we need to return promise of deps res. And now we need to go to Deno.ts, and again deps and deps, and wrap this in promise. And then we need to update our test file as well. So async function main, and we need to await Deno.deps. So we're just gonna return promise void, and we're gonna run this main function. So actually, if oh, this might even work like this. I think I'm already running on latest master, which should have top level await, which is awesome. Okay, it's not compiling. Cannot be invoked on a trait object. Why not? Why is it a trait object? Oh, I think I might be missing an import. Yeah, let's go to lib and see if file fetcher is. No, it's. Oh, okay. Match case. No. Still no. Let's see. File fetcher. Yes, source file future. Ah, okay, sorry. I don't have future imported in scope. That is bad, so this should be used futures, future. Yeah. And the other problem in here is that we should probably return a future OK with this JSON, and we should return a future inside JSON op async. Okay, yeah, we cannot use this, but that's not what we wanted to do. Okay, so let's fix this. First of all, we will return futures future OK, and then we're gonna assign this to a variable named fut and yeah. Okay, this is better. Let's see. Yeah, so top level await is not working in here, so let's go back to this main function. Yeah. Oh wait, it's a TS error, so probably if we change this test TS to test JS, we should be fine, and we could use top level await. I think it's PyCharm that is complaining. Deps await, yeah, most likely. Let's see. So deps JSON string. Why it's so let me see. We should have quite a few imports like this inside ops. So okay, futures future okay. Okay, one more thing. Use futures future, and we have this here. Expected type in this macro invocation. Okay, so this is already a string. Will it work if I remove this whole JSON macro? Probably not, because it needs value. Okay, so futures future okay is not fine. Why is that? Futures. Yeah, this is the same import. Yeah. Okay, so I have single colon. and URL is not known. Fetch compiled module. What does it return? Compiled module. Code name. Okay, so probably name. And we need to return box. So we cannot have just a future, we need to box it to be able to return a future. Yeah, so we need a value. This value is a type provided by JSON crate, and since our two JSON objects return just a string, we might have to this is interesting, because if I put it inside, okay, let's try to put it inside JSON macro once more. Okay, and we need to use this and this, and I think it should stop complaining about the lifetime. Yeah, so out is not of our interest, and then borrowed value does not live long enough. Why is it dropped in here? It's borrowed for static. Oh. Can we just ignore it altogether? How about... no, wait. So we're cloning it, and then... wait a minute. Yeah, so we have this op. And this is a promise. Yeah, and it returns JSON. Why doesn't it like this? Oh, okay, so maybe here as well. This is quite interesting, because state is fine, or is it? Let's see. So in here we have stay. Oh, okay, so here's another clone. Yeah, that might be the thing. Let's see if we clone this again. Oh, come on. Okay, let's do this for now and see if this changes anything. Nope. Does module specifier implement copy trait? No, it's clone. Well, let's cheat a bit. A equals expect, and let's pass A here. Ah, right, it's a string. I cannot copy it. That's silly. Okay, let's go back a bit. So basically the problem is that we try to use this module specifier underscore in the in and then. So this is a subsequent future after the first future, the fetch source file async. What I'm curious about is so yeah, basically this is the same situation in print file info. So we're cloning the state and we're cloning the module specifier, and it's working fine in here. Oh, okay, so right, and if I do this, does it change anything? Module specifier. No, okay, it's referenced here again. Yeah. Okay, so let's see in Rust. Okay, I'm gonna try one hacky thing once more. Args URL to string and try to do module specifier in here. Let's remove this, and let's try again. Oh, right, so this should be expect anyway. Okay. Yeah. what is strange for me is that, wait, can't we this and then I think we can like indent the whole thing. Let me do this. Let's copy this and comment this bit, and let's do like this. So after we fetch source file, let's do this, and this returns fetch compiled module returns a future, so we should be able to do and then on it and do it like this. Let's see if this compiles. Oh, this is worse. A lot worse. So value captured here. Borrowed value does not live long enough. Shouldn't it be static? No. I'm just like messing around right now. Okay, so we need one more state, like state double underscore. Okay, this is quite interesting. I'm just gonna Google it. So let's copy this whole thing. And let's see. So this module specifier is definitely not going to work. Yeah, Stack Overflow, that's it. No, not really. Wait, maybe I'm just missing something really obvious in the code. So this probably won't work. Let's try again. So fetch source file. So actually what we want is to have a reference to state in the last closure, and we need to have the URL or the name for the compiled module. And once we have those two things, we can just acquire all dependencies from the modules. Okay, I'm just gonna go to librs one more time and check something. Yeah, so this is everything's in here is using the same reference, and it does not complain. Okay, because this is not boxed, I think. So let's see, state clone. Does any other op use this? Yeah, workers use clone, that's fine. Yeah, let's see, parent state. No. State clone in here. Okay, that's fine. Okay, let's see. So we get this out object in here. Oh, it's not an object, it's a struct. It's source file, I think. Yes, so source file future, which resolves to, oh wait, it's boxed inside in here. Is that the problem? Yes, source file. Yes, so do not need this, do not need this, this is fine. So what is interesting is that this reference to state that we clone in here is working fine, but the module specifier is not. Well, obviously we're cloning the reference in here, but creating the specifier here. Oh, that's the thing, I guess. So if we did this module specifier resolution as part of the future, then we should be good to go. Let's see if we can do that. Okay, this is gonna be really hacky, so hold tight. So let future is state. No, it's not state. Let's start with something horrible. Let's do something like this. I don't know if I can do that. And then we have move module specifier. Oh, maybe we were missing move there. That'd be fun. Oh, come on, don't tell me it was this move. That's embarrassing. Ah, come on. Okay, that was fun. That was super fun. So, given that we build it, we should be able to run test.js. It's test.js. Yeah, with top level await. Let's see if it works. But async op ID. Okay, so the problem is that we added an async op in dependencies, but once we added the op ID, it was originally going to be a sync op, and we do not have a handler defined in here. It's like double check that we don't receive asynchronous response to ops that are not supposed to be asynchronous, and we said that deps should be asynchronous. So once we build it with this added case statement, this should work. And what's nice is the await is top level await is actually working. Yeah, that's exciting. Okay, fingers crossed This should work now, and we should get the nice dependency map for the file server. There's one more thing we did not talk about yet, and basically asking for dependencies is like dynamic import, with the difference that we do not want to evaluate the module, but it might be actually reasonable to add the same permission check as in dynamic import. So we should be checking each dependency if we want to download it, but we can skip it for this video, and I'll just pause the PR and see what's the feedback. So compiling file server. Oh, this is bad. Right, this is using old API, and just in 0.19 this API for listen was changed to use a single object instead of 2 arguments. So okay, first of all, let's remove this async from declaration file, and then we're gonna use some other file, not file server, as our test subject. So yeah, I think flags has some deps as well. Oh, cargo build. Okay, let's try this. Oh. So again, we're unwrapping somewhere. And okay, so let's see. Rust backtrace equal 1. Will it change anything? Yes. So what are we unwrapping? Deps, op-deps, option. Okay. Let's see. So I think we're unwrapping this guy here. Let's just quickly add eprint ln. So compiled module name. And that would be so compile.name, but I also want to do module specifier in here as well, because maybe we should actually ask for the original file. We have this strange thing with aliasing, that is, if you try to load and compile the TS file, you will see that the compiled version has .ts.js extension, but the actual file name that is given to V8 is still just .ts. So we might need to use the actual module specifier, but let's see. So yeah, backtrace, and we should have our print somewhere here, maybe. Yeah, okay, so actually both names are the same. What's the problem then? So these deps is not returning what we want. Let's investigate. So this is modules, fn deps new module name module. So this is what we okay, still again, then So we're fetching the file, we're compiling the file, but the deps API is exposed on modules, and module structure actually is used to keep track of the loaded modules. So let's see lib.rs again, because the same idea is used in here to print dependencies, and yet module is not executed in here. So your worker state modules log unwrap deps compiled name. So that's basically the same thing we're doing in op-deps. But what's the difference? Let's see. So we get this compiled source file. Yes. Okay, we're not Oh, are we? Yeah, we're executing the module during info command. That's why it's available in modules. I'm not sure we want to execute those modules that we just want to get dependencies for. Yeah, let me think. So it's fine in this info command because this is one-off command. So you type in your terminal deno info. Yeah, just let's just run it. Deno info https deno.land/std/flag/mod.ts. And actually this file is executed inside an isolate. Okay, another thing, deps. There's no deps in flags mod.ts. Oh, is that right? I think I got confused a bit. Let's go to Deno.std and see what we can use from here. So catj, no, it doesn't use. Oh, actually it uses. Yeah, that's fine. Let's try examples catj.ts, and we're gonna use the same URL for our test.js file. Let's see if that works. Yeah. So examples catj.ts. Fingers crossed once again. Yeah, okay. Yeah, so the problem is that we're loading our module, compiling it, and actually we know about its dependencies, but the dependency API uses modules, which is a struct that contains modules that are already loaded into an isolate. So well, we can do that now, but I'm like 95% sure that's not what we want to do. We don't want to execute the module inside the isolate, but I don't know if we can just register it there. Let's see. So we have this execute mod async, and that's not what we want. Okay, so recursive load. Yes. Get future isolate. Oh, okay, so maybe if we use this recursive load but don't call mod evaluate later, we'd be able to get those deps. Let's see. So we get this and we get this. Let's go to deps.rs. So we've got compiled module. I'm not sure if this is what we want. So loader self state. isolate. Oh, okay, so we don't have access to isolate inside an op, so we won't be able to do that. Why does it need an isolate? Okay, so we're registering the modules inside isolate. That's out of the question. Execute mod. Oh, this is really interesting now. So no, we don't want this recursive load. Yeah, this is cool problem because we need isolate to be able to retrieve the module dependencies, and you cannot access isolate from within an op, and you won't be able to, because we definitely don't want to pass an isolate to an op. It's like a private structure. Yeah, so we could fake this out by using import, and I'm pretty sure that if I do this, so if I first import this file, it will get registered inside an isolate as well as all of its dependencies, and then we should be able to get those devs. But of course, this is not what we want to do. We don't want to dynamically import this module before. Yeah, and okay, now we get the prompt for dynamic module. Yeah. Oh, okay. Yeah. So now you can see that inside deps, we get the dependencies in wrong format, but we do get them. Okay. So let's fix this format real quick. So modules to JSON object. Okay, because we're calling to JSON and not to JSON object. Let's change that. Let's build this real quick. Let's see if we get this to work, and that will probably be all for today. And I'm gonna think how we can solve this problem at some other time, because it's turned from quite trivial to quite non-trivial. I completely forgot about the need to register the ops inside register the loaded modules inside module structure. Yeah, this is gonna be tricky. Maybe we can just give it to TypeScript compiler to get all the dependencies. Yeah, that might be possible. Okay, let's see. And I must say, I was really hoping that you guys would choose window on unload. I think, yeah, the poll I did, I was really hoping that you choose this one, because this would be so much more fun and so much faster. But hey, yeah, you wanted dependencies, so that's what we did. Okay, let's try to run it. Yep. And yeah, so after dynamic import, okay, so I will bump this a few lines so everyone can see. So this is good. This is what we wanted to get. So we have an object that has name, that is the URL of the module, and then deps is an array of nested objects like this. But the problem is we're using dynamic import to register this thing inside isolate. And as you can see above, you have output from this catj.ts file. So this is totally out of option to firstly import it because the code gets run. Yeah, this is interesting. That's why author of the original PR did only this for Greg. So hi Greg. So I guess that's why Greg did it only for the main module, because that's what you have loaded. We could change it to work with the dependencies that are already loaded inside our program, but I'm not sure that's what we want. So what I'm gonna do now is I'm gonna wrap up this stream. I can answer a few more questions if anyone has any. And I'm gonna probably open a PR tonight or tomorrow for this stuff and talk with other guys how do we want to solve it, or just scope out this issue, because maybe we don't even want to provide ability to sniff out all the dependencies of arbitrary module from the internet. It definitely would have to be behind some permission checks. But yeah. Okay, so yeah, I can take like 5 more minutes to answer some questions, and then we're gonna wrap up. So fire away, guys, if you want to ask anything. So let's clean this up a bit while we can. So I added this eprint that can be removed. And yeah, so we can remove this unwrap and change it to, so let deps JSON string equals to match this, and if it's none, then it's none, and if it's some deps, then we'll take this. Yeah, so this program shouldn't crash anymore if we build it and then remove this dynamic import. So we just get like undefined here, or null, maybe just null. Hi Leonardo, so is any enterprise currently backing Deno? As far as I know, no one's backing it at the moment. Oh, okay, so this is option. So let's just put empty string. Luca asks if I work on Deno full time. No, I don't, but I would love to. Come on. So this is toString. Okay, so I got like the rest of the week off, so there's a good chance that I might just, fire up the cam tomorrow and work on something. So just keep in mind that if you come by my channel tomorrow, you might find another stream. Maybe it will be way earlier because it's already like evening in Poland, and since I have a full day tomorrow and the day after, I can just, you know, fire up the cam and code in here. Okay, so let's check if this won't crash. Yeah, it's just printing an empty string that deps are not found. Okay, so I think I'm gonna stop now for tonight, and I'll ponder on this problem for a bit more and we can solve it later this week. Okay guys, so thank you so much for watching and see you soon. Bye bye.